Okay, so it's important to note that there are two parameters that we've added in our modeling process that we, as the data scientists, can control setting the values for. So we saw that we can control the value for the mixture parameter, and this is the type of regularization we want to apply. Is it a ridge model? Is it a lasso model? Is it an elastic net? And we can also control the penalty. This is the size of the regularization parameter, which we refer to as lambda. So these kind of parameters that we can control during the modeling process, then we call these hyperparameters. They're tuning parameters that we have control over. And these are used to control the complexity of the machine learning algorithm. And although not all algorithms have hyperparameters, so think about ordinary least squares. We didn't have any hyperparameters to deal with. We just applied the model. But more advanced algorithms, and as you see, when we go on to future modules and we start introducing some new, more advanced algorithms, we almost always have hyperparameters that we can adjust values for. And we go through a process of iterating over different values to test them out and kind of see how they affect the results. And the idea is we continue to kind of tune these knobs, tune these hyperparameters, until we can find which values provide the optimal result. Now, in next week's module, we're actually going to go through the process of learning how do we appropriately tune these hyperparameters. Because there is a process that makes it easy, simple, and more efficient to do. In this case, for right now, what we're going to do is just manually adjust some of these hyperparameters, kind of see how they impact our results. All right, so for example, we can tune the regularization strength. So recall that this is that lambda parameter, and it's controlled by penalty here. So the size of this penalty determines the strength of the regularization that we're going to apply. So in the original examples we showed earlier on, we used a penalty equal to 5,000. That gave us an RMSE of 31,373. If we were to increase this to 10,000, now we see that our cross-validation results ends up being 30,999. So we've seen a decrease by increasing that penalty. And we can go through another iteration. Let's bump it up to 20,000. And in this case, we see a slight decrease as well. Now, this is not always the case. Just because we are seeing improved results by increasing this value here, that does not mean that that is always the case. In this value of why we picked 20,000 or 10,000 as in the last example, right? That is, it's not always the case that we're going to use values of that magnitude. We should also assess or kind of adjust the type of regularization we want to apply, right? So in this case, we've been using mixture equals 0 so far. So that's always been applying a ridge model, but we could adjust mixture equals 1. And now we're applying a lasso model. And so now we have a lasso model where we're using 20,000. In this case, our five-fold cross-validation gives us 48,675. So we lost quite a bit of performance from going from a ridge model with this penalty to a lasso model with this penalty, right? So we're not seeing an improvement there. We could also take a look at an elastic net. So here we change mixture equal to 0.5. So this is a 50% ridge model, 50% lasso. We're combining that penalty. And now we see our k-fold RMSE is 39,000. So we saw improvement from the lasso model here, but we're still not doing as well as the ridge. So right now, just based off of the few iterations we've done, we see that it looks like ridge model is performing best with this data set. So unfortunately, using the same penalty value across the different models, that rarely works, right? So in these examples that I just showed you, we went from a ridge model to a lasso to an elastic net, but we use this penalty of 20,000. That is rarely the case. Often there is this interaction between the value of the penalty or the size of the penalty in the regularization type. So it requires us to test out a whole bunch of different combinations of these. Larger values maybe with ridge, smaller values maybe with the lasso, somewhere in between with elastic net. And this can become very tedious and time consuming, but don't worry, in the next module we're going to see how we can actually automate this process to find which type of regularization performs best and with what size of a penalty parameter we want to use.